Okay, we are back on the Hoglet, and this is the start of one of the cylinders. I've already kind of roughed it to size and laid out a few things, and this is just a long and tedious job, so I won't bore you with every single cut, but you'll get the idea. It is pretty interesting, the layout, and I'm going to end up making a line boring tool for the lathe to do the finished cylinder size. Make sure it's nice and square, because this is a small lathe, and all I have is a tool like this with this huge reach that I'm sure has some flex in it. So I want to try on the finished part making a line between centers line boring tool. That's what I'm going to be doing. So here we go. So we're going to bring this measurement here down to bring it down to 1.186, and I'll bring you back when we get there. So we got our section here down to size. We were looking for 1.186, and I came in, I don't know if you're going to be able to see that, I came in at 1.18, almost 6, but it's between 5 and 6, closer to 6. It's almost pretty close. Not bad for a Chinese machine from an amateur. So now we got to bring this all the way down. We got to cut this down to size, all the way from this edge to here is 1.064, and we're going to take that all the way down, and then there's another cutout between here and here, and it's just part of the process. We'll bring you back when we get closer, and here we go. So we're going to give it a quick measure and see how much more we got to take off. And we have 1.400 is our goal. I think we got a lot to take off. This is a little bit bigger than 2 inches when I started. So let's see where we're at now. Come on, baby. Yeah, we're at 1.975 pretty much. So we got yeah, we got 0.5 to take off. Half inch. Almost a half inch. Well, let's get after it. So we're creeping up on our next dimension, which would be 1.400. Let's see where we're at. We're at 1.414. So I got like 14 thousandths to take off. And we'll do it in 2 cuts, I think. 2, 4, 6. Let's see what that does for us. Okay, we got 7 thousandths. 2, 4. Let's do that again. I don't know how accurate my little tick marks are here, so I don't rely on them. I should have a dial indicator on the other side here, but there's not enough room the way I got it set up. So we just creep up on it. One and a half. Yeah, ain't much. I'm gonna do it like this. Let's see where we're at. Probably pretty close. I think I went too much. Yeah. 1.399. If you don't tell, I won't tell. How's that? So now We have more to take out. It's going to be a little step, and then this in here across to there is going to be down to another dimension. So I'm going to get that laid out, and we'll go from there. So what we're going to do next is we're going to mill out a little bit of this by the blue here. What that is this part here, smaller diameter, sits on top of the engine block in a hole, recessed hole, and this section right here keeps it from going through that hole, and then this will be reduced to match what the fin depth is. This is all going to be the fins for the cylinder for cooling. So what we have to do is make this little stop. It's just not much of a stop, but it's 0.188 in diameter. So we go 1, 2, 3, 4, 6, 9. So the issue is I don't really have the best tooling for this. So I have to play around with what I have. So I'll show you what I mean. Do is change my tool to start cutting this way. I'll try to get most of it cut out, and then I'll come back in and finish that. It's kind of a pain, but let me get it reset here. Yeah, I need to get some better tooling. Well, I'm using cut-off tool just to square up my edges. And what I'm worrying was kind of hard getting it cut because I didn't have the right tooling. So use what we have to. how close that is. It's probably under now, I would imagine. Oh yeah, we're under by 4 thousandths. I can live with that. I can live with that. Let's give it a little deburr here. Now what we're going to do is we're going to put a steady rest right here, right there. We're going to take this away, and we're going to bring in some drill bits and drill a hole all the way through here to a nominal size that I can use to get my boring bar through, and then we'll be really making some headway. So let me get that all set up and we'll get back to you. So I'm sure any of you that have a cheap Chinese lathe like me has seen one of these, and they used to come with these little brass things that just did not work very well. So took some aluminum pieces and I got some little ball bearings, and I just put new pieces in. It seems to work much better. So I can get this thing here set up. And get it supported. Let's see here. That should work. That should work. Right. Now, get that snug down. Then, put a little bit of light pressure on it. Gotta loosen that up. Put a lot of pressure on these, but I want to square up everything, right? So that should keep us pretty straight. It worked before, so we'll have to see. Now, don't need this. Get everything set up, get back to you. So, what I have is a 3/16, they call it an aircraft bit, it's like 6 inches long. And I'm going to drill a hole. And the reason I'm going to do it the way I'm doing it is because these bits will drift. So I'm going to drill this, and then I'll drill in like a 5/8. And then I'm going to go through with the boring bar to make it as big as I can, and then I will do the between centers boring once I get that all figured out. So. Possibility of breaking your bits. So it's a lot of in and out, slow movement. So now it's time to move up to 5/8 hole, which is going to allow me to use the boring bar to get it close to nominal size so we can do the between the centers line boring. Through. There it is. There it is. So here's the setup. On this little lathe I got, there's just a lot of limitations, obviously, and with the length of the cylinder and the holder and this here all coming together at the same time, the only way I could make it through with a boring bar was to extend this way out. And I got the biggest one I could for the equipment I have. I probably could have got a whole different head here, but what I'm going to end up doing, like I said before, was I'm going to do a between centers boring bar. And once I get this bored out to a nominal dimension, which I'm aiming for 0.94, then I can put my between centers boring bar in, square it up to this hole, and get hopefully a much more square and straight bore, because I just don't think that with this extended out so far that I'm going to get the bore that I like. So for now, this is what I'm going to do to get it to a nominal dimension so I could put my between centers bar in. So here we go. Taking 20,000 at a time, and we'll run through a few times and see what we end up with. It doesn't look like it moves back and forth because I'm taking such a light cut. But I would imagine if I tried anything heavier, it would deflect and not cut correctly. So it's a time-consuming project. And, obviously, I don't want you to watch this whole thing, so I'll get back to you. So, this is going to be the final pass on the rough bore, and it's basically going to be a spring pass. I can tell just how much that flexes every time I try a spring pass on this. I guess I'm going to need to upgrade my equipment so I can get a bigger boring bar, but hopefully how it's going to work is once I get this rough board to 0.94, right around there, then I'm going to do that between centers boring, which should give me a more square or straight bore compared to the outside. I think that with the equipment that I have, that's my only way to really do it properly. I have a mill, but I don't think I would still have to use a long boring bar to do that, and my mill might not have that rigidity to give me a real straight bore. And I know it's not a high-tech 8,000 RPM racing engine, but I want to try to get it as close as I can. Just because why bother if you don't, right? So we'll see how this comes out with this spring pass. I can still hear it cutting, and some areas are cutting more than others, which leads me to believe there either might be hard spots in the cast iron, or there's just that much flex in the boring bar. So it's almost through now. Let's take a quick measurement. It's going to be, doesn't have to be right on 0.94, but if I get close to that, that'll give me a starting point to give me plenty to cut out with that between centers boring, because I want to end up at 0.99 or 1.0. So that should give me enough if it isn't square. I hope, anyway. If not, maybe we'll put a bigger piston in it. We'll have to see. But let's see where it takes us. Let's see where it takes us. And I'm doing it with the guesstimeters here. We're at 0.948, which is close enough for me. So once I figured out that this whole piece right here does in one setup, it was actually pretty simple. A little time consuming with this equipment, but simple. Come on, baby. If by chance I ever have a chance, I wouldn't mind getting something bigger, but I guess if I can do it on this one, I can do it better on a new one, right? That's what I'll have to tell the wife. Look how much better I can build my little toys, because that's all they are. A pastime, right? I think we all agree on that. Just a pastime. So let's see what it looks like, and then we'll get it all set up to do the line boring. I'm going to have to make a jig for that. I'll do that separately because I don't know how to do it. So I have to do some research, and through the magic of editing, it'll be like it never happened, right? Alright, let's get this out of there. There's our piece. there is our piece. There it is. Not bad, huh? So we'll see how square it is on both sides as far as measurements go. Maybe I'll use a spring gauge to get better measurement. But we did all this in one setup. This, and the bore. So hopefully it ran nice and true doing all that. And after I do the inline boring, then we're going to cut all the grooves all the way down here for the fins on the cylinder. So stay tuned. If you like it, subscribe just to watch. Thanks.